Okay, so today we are comparing elements and compounds. So our essential questions for today's slides are how can we compare and contrast elements and compounds? Hopefully we know what compare and contrast means. Compare, what do they have in common? Contrast, what do they have that's different? How do atoms, molecules, chemical symbols, and chemical formulas help us distinguish elements and compounds? So think about what you already know, and we'll go from there. So matter, this should be a review. Matter is anything that has mass and takes up space. Matter is made of atoms. It makes up everything. Sometimes you'll see a joke about that. Matter comes in three states, so solid, liquid, and gas. So the solid is very tightly packed. They don't change shape. Liquid is slightly packed, like it's kind of packed together, but not really tight, and it will change to shape to fit the shape of the container. And a gas is not packed at all. These molecules are moving around really fast, and it will take up as much space as you give it. So the solid state of matter, here we will talk about these again. It has a definite volume, so it has a certain amount of mass inside of it, and it has a definite shape, so it does not change shape. The particles are tightly packed, and it does not flow easily because the particles cannot move or slide past one another. They are very tightly packed, so they're not going to move around. And so ice is water in its solid state of matter. Hopefully you know that by now. Liquid is the next one, so it has a definite volume but no definite shape. It is fluid, so meaning that it flows easily because the particles can move past each other. It has free space between the particles, and it takes the shape of its container. So if you pour water, because water we drink is water in its liquid state of matter, if you pour water into a glass, it takes up whatever shape that glass is. If you put it inside of a bottle, it's now the shape of the bottle. The water will not expand to like fill up empty space, but it will change shape based on what you put it inside of. Our last state of matter is gas, and when matter is a gas, it has no definite shape and no definite volume. It has lots of free space between particles, so these particles are very far apart. It is fluid and flows easily because particles can move past one another and are far apart. And it takes the shape and volume of its container. So steam is water in its gaseous state of matter. So like if you think about air, air is a gas, and if you have a certain amount of oxygen or nitrogen or helium, if you put it into a room, it's just going to expand to fill up the entire space you give it. So it's going to change shape, and it will just keep stretching out to fill up all the available space. Elements. So we learned that atoms are the building blocks that make up everything. That was our last video. And these atoms that make up matter are called elements. An element cannot be broken down into any other substance. So when it says it cannot be broken down, it means, so you can break down an atom into neutrons, protons, electrons, but a proton of one element, like oxygen, looks exactly the same as a proton of another element, like lead or silver or gold. All their neutrons look the same. All their protons look the same. When you say you cannot break down an element, it means that you cannot break it down anymore and have it still be that element. So if you take oxygen and you split apart its atoms, it doesn't look like oxygen anymore. It just looks like neutrons, protons, and electrons, right? So an element is the smallest piece you can have and still tell what it is. So you have one atom of gold, or one atom of lead, or one atom of oxygen. So you cannot break it down any further and still tell what it is. Hopefully that makes sense. So brain break. So use your knowledge of matter to figure out the mystery substance. So this substance has no definite shape. The substance is used often at birthday parties. It has no definite volume. It is an element on the periodic table. It floats when in atmospheric oxygen, and the substance flows. Okay, so when we take all of those clues, it has no definite shape and no definite volume, so we know it has to be a gas. It's used at birthday parties. It's an element on the periodic table. I'm thinking this is helium because you use it in balloons at birthday parties. It's helium. Okay, so elements. Elements are represented by a chemical symbol, and symbols always have one capital letter. So every symbol will always have at least one capital letter, and sometimes they have a second lowercase letter. So for example, sulfur, its chemical symbol is a capital S. Neon, its chemical symbol is a capital N and a lowercase e. This one right above me is a really good example. So that is aluminum, and we know because you will not have two capital letters in a chemical symbol that this is a capital A and a lowercase l. So a lot of kids will always think that that's an A and an I, but you won't have two capital letters in one element, okay? So it's a capital A, lowercase l. A lot of people will also ask about ones like this, like AG. Why is gold, is that gold? Silver, sorry. Why is the symbol for silver AG? Gold is AU, right? There's not an A or a U in gold. There's not an A or a G in silver. And a lot of those elements that have symbols like that are elements that like people in ancient times could dig out of the ground and find very easily. And so they were named in Latin. So AG and AU both have Latin roots, and so that's where those symbols come from. If you look at like oxygen, it's just an O, and that's because ancient people didn't know oxygen existed because you can't see it. Okay, so, and they're actually just talking about this. So some chemical symbols are based on the Latin name for the element. So for example, the element silver has the symbol Ag, which comes from its Latin name argentum. So I literally just said that. So what do all element symbols have? They all have at least one capital letter. Some have a second lowercase letter, but all of them have a capital letter. So elements, many elements are all around us. Some are solids, some are liquids, some are gases at room temperature. Any element can be a solid, liquid, or gas. It just depends on the temperature. So there are 90 elements that occur regularly in nature, but most of our world is made up of just a few elements. So on the periodic table from 1 to 92, actually, all of those can just be found in the world naturally. Anything above 92, so 93 to 118, I think is what they're up to now, have been artificially made inside laboratories. So those are things scientists have put together. So atoms of the same element share properties. So they have the same atomic number. So like every atom of oxygen has the atomic number of 8. They have the same atomic mass, the same reactivity, the same melting point, which is the temperature where they change from a solid to a liquid. They have the same density, and they are the same state of matter at room temperature. So you know if you have an atom of oxygen and another atom of oxygen, they're going to behave the same way in all of these different ways. Okay? So they are the same element, they're going to act the same way. So elements are represented on the periodic table by their symbol. So this one is carbon, so it's just an uppercase C. At the top is the atomic number. Remember, we said the atomic number is based on the number of protons. So carbon has 6 protons in its nucleus. And at the bottom is their atomic mass. So you would add together the protons plus the neutrons to get your total mass. So the atomic mass of carbon is 12.01. So basically 12. So there's 6 protons, because we know that from the atomic number. So that means it must also have 6 neutrons to add up to 12. So take 1 minute to write down as many words as possible using the symbols from the elements. So for example, you can make mother, M-O, and T-H, and E-R. Can you write your name from the periodic table? I think I can. A-M is Americum. A-N, is there an A-N? I don't remember. Maybe I can. Some people can write their name with elements. I'll have to check. All right, so let's talk about Dmitri Mendeleev. He is kind of a big deal. He's not as big a deal as Newton, but he's still pretty important. So Dmitri Mendeleev was a Russian chemist, inventor, and teacher. And to help better understand the properties of elements, he arranged the elements into the periodic table. So he's the reason why we have periodic tables posted on our walls and stuff. And so he arranged them by increasing atomic weight and other similar properties. He was even able to predict the properties of 8 elements yet to be discovered. So he was able to figure out these elements behave in certain ways they should go in these groups and periods, and we'll talk about those in another lesson. But then he was like, there are gaps in kind of what I'm seeing, so there's probably an element that I don't know about that fills in that gap. Super smart guy. Not sure what is going on my screen. All right, there we go. Okay, so think about it. You are trying to determine Mendelev's missing elements. Use the data below to identify the missing elements and explain what properties led you to your answer. So he had these here, and then he had gaps in his periodic table. So use the properties you see here to figure out what might be what's missing. It's a little tricky. All right, so compounds. So matter can also be made of compounds. And compounds are formed from two or more elements. So the different elements are chemically combined through a chemical reaction to form a new substance. And again, we will talk about bonding and chemical reactions later. One thing I do want to point out, and maybe it's on the very next slide like I did before, is that if you have two oxygen molecules, so you may see like O2, like an O and an O together, that is still an element because it is just one type of atom. It happens to have two of them combined because that's how oxygen is found in nature, in the atmosphere. It's almost always combined with another oxygen, but that is still an element. Even though there's two atoms of it, it's only one type of element, so then it's an element, not a compound. Compounds only happen when you have two or more types of elements or atoms. So here we have sodium chloride. This is salt that we put on like popcorn and chips. And it is sodium, so one sodium, so Na atom, and one chlorine atom, one Cl. So again, because it's a capital letter and a lowercase letter, we know the second letter has to be an L, not an I. So capital C, lowercase l. This one here is nitrogen dioxide. And so that's just another gas that might be found in the atmosphere. So it is one nitrogen. Di, when it comes to science, means two. And so we have one nitrogen, two oxygens. Okay, so where can I put myself up here, I guess? All right, the different elements that make up the compound are represented by their symbol in a chemical formula. And you may be familiar with the chemical symbols for the elements sodium, Na, and chlorine, Cl. When the two elements are chemically combined to make a compound called sodium chloride or salt. Its chemical formula is NaCl. So you just combine the two elements together and it gives you your chemical formula. So later we will learn about what the small numbers mean. And so for now, recognize a compound when you see two or more element symbols together. So here we have HO2, H2O2. And so that is one chemical formula. And this is what it looks like, the model. This one is H4P2O7. So that is just a bunch of different atoms put together into this compound, which is called pyrophosphoric acid. I knew that. All right, so quickly you would decide if these are elements or compounds. So hydrogen, sulfur, and oxygen. It has three of these things together. That'd be a compound. If we have just helium, then that's an element. This one is chromium, nitrogen, hydrogen, and oxygen. So you have four different types of atoms. That's a compound. Magnesium, nitrogen, oxygen, compound. Barium, phosphorus, oxygen, compound. Oxygen, element. Hydrogen, phosphorus, oxygen, compound. Zinc, oxygen, hydrogen, compound. Carbon, element. So again, if you have just one type of atom, so helium, oxygen, carbon, that's an element. If you have a combination of two or more types of atoms, then that's a compound. So counting elements, let me see, I can go down here now, okay. So elements can chemically combine with other elements to make compounds. And a compound will always have at least two elements. And we can tell how many elements are in a compound based on how many different chemical symbols we see. So the easiest way to do that, count your capital letters, okay? So in this compound, we have two sodium, so Na2, and then an O. So we have one capital letter, and then we have a second capital letter. So we know that this compound has two different types of elements inside of it. So just count your capital letters. If we had NaCl, like we did with table salt, again, two capital letters, a capital N, a capital C, two elements in that compound. All right, so we're gonna look at these. Rearrange the circle pieces on the right to make 4 whole circles with the correct information inside. We're not gonna do that. Okay, all right, so compounds and molecules. Compounds have different properties than each of the elements that make it up. So compounds have their own unique physical and chemical properties. However, the molecules of a type of compound share similar properties. We'll go through what that means. Apparently we won't. Okay, so compounds, when you have like NaCl, you have one atom of sodium, one atom of chlorine. You combine them together, you have those two things combined, that's called a molecule. When you have an NaCl combined, that's a molecule. Na, so sodium by itself, is a solid silver metal at room temperature, and if you put it inside of water, it catches fire. It's really cool. Chlorine, at room temperature, is a gas. It is poisonous. If you breathe in straight chlorine, you're not doing well. So these have very bad kind of properties by themselves. If you combine sodium and chlorine chemically, now you have NaCl, which is sodium chloride, salt, and it's completely fine. You can put it on your mouth, you can put it on popcorn, you can eat it, it's fine. It's so weird. These two things by themselves are completely different, and then when you combine them, it's something completely different, which I think is so cool. So by themselves, dangerous. Together, delicious. All right, so think about this. You're a forensic scientist analyzing a crime scene. You discover two powdery substances, one white and the other yellow. Your job is to determine whether they are the same compound or different compounds. How would you utilize appropriate lab tools to distinguish between the white and yellow powders? Provide a detailed explanation of the tools you would use and the steps you would take to reach a conclusion. So how could you figure out what these things are? What do you think? All right, so let's talk about molecules now. So like I said, we touched on this a little bit. So similar to how atoms are the smallest unit of an element, molecules are the smallest unit that keeps the chemical properties of a compound. What does that mean? So consider the example of water. It has a molecule of water. So here we have two H's, so H2O. You guys know that chemical formula before I even told you that's what it was. So two H's, so H2O. That's a molecule of water. However, it's also a compound because it is made of 2 atoms of hydrogen and 1 atom of oxygen. So this is a molecule because it is one part of water that's all together, but it's also a compound because it has the 2 different types of elements. Dividing water anymore would create atoms of hydrogen and oxygen, elements which are gases. So just like when we said that an atom cannot be broken down anymore and still be an element, so like you can't break down a molecule or an atom of gold anymore because then you just have a proton and a neutron and an electron. You cannot break down this water anymore because you won't have water anymore. You'll just have hydrogen, and oxygen. So once you start breaking these things apart, they stop being what they were before. Once you break gold apart into its pieces, it's no longer gold, it's just protons and neutrons. Once you take water and you break it apart, it's no longer water, it's hydrogen and oxygen. Right? So you have to have at least a whole molecule for it to be water. You have to have a whole atom for it to be gold. Okay, so you have to have the whole thing for it to still have those properties. So dividing water anymore would create hydrogen and oxygen, elements which are gases. So this one is methanum. So this has 1 carbon, 4 hydrogens. And again, you need all 5 of those combined to have a molecule of that, right? If you break it down anymore, then you'll just have hydrogen and carbon. So a molecule is any 2 or more atoms bonded together. And some elements can occur naturally as molecules. They have 2 or more of the same atom bonded together. So this is when I was talking about oxygen. In the atmosphere, oxygen is almost always combined with itself, and so you'll almost always find 2 oxygens together in a molecule. It's still an element because it's one type of atom, but it's one molecule because it's 2 atoms combined. And molecules that are compounds have 2 or more atoms of different elements. bonded together. So for example, we have this H2O, which is again water. So this is a one molecule of water, but it's also a compound because you have two different types of atoms. Here we have one molecule of oxygen because it's two atoms combined, but it's an element because it's the same type of element. Okay, so your classmate is struggling to understand how water is a compound, but oxygen is a molecule. Explain the difference and relationships between a compound and a molecule. So how are these things similar, the compound and the molecule? Because this is a molecule, but it's an element because it's just one type. All right, so read the descriptions below. Notice there are extra bold words in each, and you would look at, we're not going to do this because you can't drag it because it's a video. All right, so how can we compare and contrast elements and compounds? How do atoms, molecules, chemical symbols, and chemical formulas help us distinguish elements and compounds? And if you still have questions, let me know. I will post several videos on ManageBac so that you can review that and hopefully get some more clarification if you need it.